Hello, welcome back to Learn It from a Layman. I'm Carl Christensen, back with Matt and Cameron. Without Johnny or Tim today, we'll be docked from their pay, so don't you worry. Though no one gets paid, so I guess I need to worry. Um, Today, we're going to be talking about object-oriented programming. So you may wonder to yourself, if you're not a software engineer, how is this relevant to me? Why do I need to know anything about this? Well, you already clicked on the podcast, so maybe you've already answered that question for yourself. However, if you have not, object-oriented programming is, I think it's helpful to kind of understand how software engineers, coders solve issues, the mentality and the organization behind it, because it's a way you can approach problems in life, honestly, a way to organize information and structure issues and data in life. And it might not be the way that you would normally do it or the way that you've kind of become accustomed to do it, but I think it's a very useful way of looking at data and structures. And so I think that across the board, this can be at least informative and useful, if not practical, I guess. However, for some of you, this will be practical, and many of you probably are the ones clicked on this podcast for that reason. So let's start talking a little bit about object-oriented programming. I guess the first thing I wanted to do was actually talk a little bit about scripting. So for you non-coders out there, people that don't have any really experience doing computer coding, a script is the idea that I need a particular thing to happen, and I don't want to have to go through and make it happen myself every time. So let's say every time I start my computer, I want these three programs to open, and I want to download this file from the internet. Well, I don't really want to have to do that every time I open my computer. So I'm going to create a script that says, open this one, open this one, open this one, and grab this file from this URL and pull it down. It's very much this is exactly what's going to happen. We have a script, as in like a movie script. These are the words that are going to be spoken, and so we know what's going to happen, right? That's kind of the idea of a script in code, and there are scripting languages in software. I guess a quick aside here is that there is a difference between scripting languages and programming languages. So like a C# or a Java versus a JavaScript or Perl, a number of different languages. And those languages, these scripting languages, can and sometimes are used for the kind of more complex user input organization of data that we'll talk about with object-oriented programming, but they are fundamentally different, and I'll mention that in just a minute, what the differences are kind of between a programming language, more traditional programming language, and a scripting language. But this is kind of more establishing the difference between a script, just a specific set of commands, and a more complex object-oriented program.
It's just telling your computer to run through a specific routine.
Exactly. Yeah. There's a particular expectation. We know what functions we need to do. There's not a lot of variables involved, at least not newly input variables. So another distinction between scripting languages and normal programs is that scripting languages aren't compiled. We won't talk much about compilers or at all today about compilers, but we do need to just understand the basic distinction that scripts are interpreted directly from the code, as programs are compiled down into a machine readable executable. So that's one difference, but like I said, the generic higher level difference is that scripts are easier, less complex, more modular, so you can pull them out. They need to be hosted by another program, but they run those step-by-step processes where code is more nuanced, more complex, and more directly read by the computer. That's kind of the idea of a script. So you go away from a script, then you have, okay, well, what if we've got user input? What if different data gets put into the system, different programs, different information that we're dealing with, and all of a sudden then you have to deal with new structures, new ways to solve this. And so object-oriented programming is methodology behind I think all software engineers day-to-day coding these days. There is a lot of script writing still, but by and large, everything that all the programs that you're familiar with, if you got into their software code, you'd be looking at object-oriented programming features of the code. You'd be looking at some of the things that we're going to be talking about today. So what is object-oriented? So the idea is just like we have in life. So let's do with some real world examples here. I'm going to take a company, right? A company can be an object, right? So we got one company, let's say Microsoft, okay? So Microsoft is one company. How many companies are there out there, right? Tens of thousands, hundreds of thousands. So each one is a separate object. Now, each company has particular nuances, different things that they do, but they also have different rules that they have to abide by, and the general structure that you can assume in a company, right? There's going to be a leader, so a CEO. There's going to be different organization leaders, so either VPs or directors or managers. And then there's going to be different employees that take on different roles, different functions. And so in object-oriented programming, that's the idea as well. Is anything that you look at, any data, you can organize into a particular structure and create this object. So in a very basic computer science classes, one of the very common programs that you're asked to write is a draw program. So you've got you need to create multiple different types of shapes, for example, and you can assume that a shape is an object. So this will kind of get us into some of these principles of object-oriented programming. Before I dive in, Matt or Cameron, any questions about that kind of at a very high level?
Well, just at a general level, it seems that when you talk about scripting, you're talking about setting up a computer process that doesn't have to really react to anything, doesn't ever have to change. But when you want to put together a program that can more easily react to different influences or inputs, then object-oriented programming is a easy way to organize your data structures to help you create that reactive program a little more effectively.
Yeah, exactly.
Fair to say?
Yeah, I'd say that's a good characterization of a script versus more of a traditional object-oriented program. So yeah, what you get here at Learn It from a Layman is you don't get the polished, well, whatever. Good job, Matt. That did sound correct. So, all right.
I could help.
Okay, so the 4 principles of object-oriented programming. A lot of these kind of overlap. So as I'm explaining these, don't feel like you are getting confused if you think these share a lot of the same ideas across them. But the first one is encapsulation. So the idea is if I'm creating an object. That object is going to have certain properties that are not publicly available. It's the idea of being able to create this distinction between this is something that the public can see, and this is something the code itself keeps internal that nobody else really needs to know about, but we need to track inside of the code. And so for example, I work my company does C# as the primary programming language. Now, in most people and most developers, you deal with multiple languages, and there are lots of languages out there. There's Java, C#, Python. I could go with C++, C. There's lots of Ruby, lots of languages out there. These elements that we're talking about right now go across all of these languages. As long as they are doing object-oriented programming, these principles apply, even if there are different words for them, different structures in that programming language. The principle remains the same. So encapsulation in C# that I use for the most part is mostly you can see it in some modifiers you put on when you create a new object. So when I'm creating a new company object in my code, I can say this is a public company, right? And that exists in the real world too, right? So if I'm a public company, that means I have certain information that I have to give out to the public. Um, my stock is traded. I have to report my finances, all these different types of things, right? Versus a private company that can keep a lot more of those things internal. So that's kind of a real world example of saying, okay, this is how it would work in the real world. This is also how it works in object-oriented programming. Encapsulation, meaning I've got certain things that I'm going to keep inside methods. So a method in software and computer engineering is a particular function. It's something that's going to take some input and give you an output or do a task.
At a slightly more abstract level, would it be fair to say that encapsulation is just a way to organize the different attributes of a certain class of object?
Yes, it's more than just the attributes. So there's properties and fields, and so that's kind of the attributes, meaning a
Yes,
property.
I'm using a layman term rather than the technical terms that our audience may not be familiar with.
Right, exactly. So you can imagine in some case a class just holds information. It's just a way to structure the data, and in some ways a class or an object is just it is a way to manipulate that data. And so there's what's called methods, and that's the way you're manipulating data. You're changing things. You want that object to do something versus a field or a property. You're saying, okay, this company has 100 employees. There you go. And maybe in the future I want to update that, but that's not what we call a method or a function. It is a property or a field, right? That's something that I may or may not want to expose to the public, but it's just information about that object. And by the way, I'm using I'm going back and forth between saying object and a class. A class is the structure, right? It's the idea of that object. And then as soon as I create an instance of that class, meaning I'm going to say, okay, here's the structure of what companies are going to look like. Now let's create one on the computer. Say now, okay, computer, I've got the structure for you. Now I want to in memory create one of these, and these are the information I've got about it. This is
so an analog could be a class could be a car. The instance of the object would be the car that you bought at the dealership that is parked in front of your house.
Right, exactly. Right. So, and once again, encapsulation is the idea that your car has got a lot going on under the hood, but you don't have to worry about, and they won't even tell you about a lot of the things going on underneath the hood. Right. So let's move to abstraction. And so this is the next principle of object-oriented programming, and that's that idea as well. So abstraction is the idea that I will not allow two of these. This code will only expose high-level functions. Like I don't want if I go to sit behind this car, right, that I just bought, I don't want it to ask me when do I fire the spark plugs, or how much gas do you want, how many liters per second do you want me to allow into the engine. I want to say accelerate, decelerate, on, off, windshield wipers, right? Like that's pretty much it. I don't want my code to expose like, oh, how do you want me to do this particular function all the way down at the nitty gritty. I want to expose like create this object. Great. Do you want me to open this file? Great. You don't need to know like I'm reading it off the disk right now. How many, what rate do you want to read this off? And all those types of questions are not exposed to because of abstraction. I want to keep these parts of the code abstract from each other. I just want to create particular high-level methods. And one kind of related idea behind this is kind of an interface. And once again, in the real world, we experience interfaces all the time, right? So our phones, we have an interface that we interact with. I turn it on, and then all of a sudden I've got a few buttons I deal with, right? That's part of the interface. I can open, I can close, I can go back. And so that's an interface. In coding, that's the same type of idea, that I've got, let's say in code, I've got interfaces as in like user interfaces, but then I also have interfaces that I deal with other parts of the code, meaning I've got a company here, and now I've got a government object over here. This company has to deal with this government, and the government needs to know, okay, what can I expect from this company? How do I figure out what methods, what functions, what information exist inside this company? And so this company is going to say, look, I have this contract, this promise that these are the things that you can get from me. You can get from me number of employees, you can get revenue, you can get profit, whatever that list is, and that's what I'll give to the government. I'm not going to tell you, how we go about our day to day. I'm not going to tell you about the particular trade secrets that we might employ. This is the high level information. That's my contract that I'm going to give to the government. And so that's in coding, you're going to see, and usually classes can implement an interface, and an interface can go across all kinds of different objects, right? So or different classes even. So not only a company, maybe a person can also implement the same interface, right? Because if I've got information that I can also give to the government, and so interface tells the government what they can expect if I say, oh, here's this contract, you can expect this from me. And so that's the idea of, once again, abstraction. I don't want to tell the government everything about what I do or what my company does, but there are certain expectations that I can hand, and if I do that in a structured way, an interface is a way to do it. And in coding, you can generally see an I, the word I prefixes the name of the interface. And so an I company would say, oh, you can expect from me the things that companies do. You don't need to know anything else about me in order to work with me. All you need to know is I implement. That means I have the same information and can manipulate the data that a company does. Maybe I'm actually a person because I'm just an at-home business. I'm a single, my own business essentially. You don't need to know that about me, though. You need to know just that I exist as something that you can get that information of a company about. So once again, does that make sense, Matt or Cameron? Any questions?
I think that's a good initial primer there.
Okay. All right. Let's move on to inheritance then. Inheritance, the third principle of object-oriented programming, and that is the idea that if I am a shape, let's go back to that, one of the original, if you're in any basic computer course, often you're asked to create this kind of draw program, and if there exists a shape, okay, and the shape has particular information that you already know because it's a shape. It has a number of sides, it has an area, potentially a color, something like that, right? However, there are different types of shapes. There's circle, square, rectangle, or lots of different instances of this shape that are their own unique classes or objects, right? And so that's, and however, if we can organize these all underneath the idea of a shape, then once again, if I'm dealing with abstraction here and I was telling some other program, oh, look, we create shapes, a shape can give you information about the area and the color if that's all you want to know, as opposed to, and then we can reuse that code also, right? Instead of having to have each class say, what's my area, figure that out. What's my color, figure that out. The shape class can figure that stuff out. And then each class can only do the specific things that it needs to do. For example, obviously a square is going to need to draw 4 lines, right? That connect and make a square. So that's not something a shape could do for it in the code. That's something that the class itself has to say, oh yes, I'm a square, this is what I need to do. Each one of my sides needs to be the same length. And so that's the idea of inheritance is I am a square, but I also inherit from a shape, meaning I'm going to get the color, I'm going to get whatever shape attributes there exist also. Whatever data structure is on a shape can also be applied to me because as a square, I'm also a shape. But I'm not going to share the same information with a circle because, well, that's a sibling. We don't share the same attributes as a parent. A parent object is that inherited object. And so you can do that all the way down the line, right? You know, a rectangle is also a square. So all of a sudden now I'm not only inheriting from, anyway, you can further go down that line in a lot of different ways. And for example, let's actually take an example of a company, right? I'm a software engineer, so I have very specific information that you know about me from that and different functions that you can expect from me. I'm also a member of our research and development part of my company. And so that's another class, another object, another inherited information that I get because I'm an instance of a software engineer. Right, so my object is software engineer, and I inherit from a research and development employee. Right now, research and development employees inherit from generic employee. Right, and so a generic employee, you can expect hours worked. You can expect years in company, those types of information that then percolate down that cross as a software engineer inherits from research and development inherits from employee, and so as a software engineer, I also inherit engineer. So that's the idea behind it. As a software engineer, I also inherit employee. So let's move on to polymorphism. And that's related once again. Like I said, all of these are interrelated. Polymorphism is the idea that as an instance, meaning I exist as a software engineer, I'm also an employee, right? And so in some scenarios, I just act like an employee. I don't act like a software engineer when I go to the company party, right? We're all just employees at that point. No one is sitting down and coding at the company party. Everyone's just acting like a normal employee. So also in code, when you are doing particular manipulations, you don't want to have to deal with these different objects in different ways. You just want to know, give me the employees, and I want to do something with all employees. And so now, even though I am an instance of a software engineer, I'm morphing into an employee, and this is polymorphism. So I can morph in different ways depending on what I inherit, right? All of a sudden, I'm no longer an instance of a software engineer. I'm an R&D meeting attendee, right? In which case, I'm not specifically doing what I do as a software engineer. And so that's the idea in code, that I need to be able to take on different shapes in order to be manipulated for that specific method or function that is changing the data or dealing with me in a particular way as an object. Okay, so those are the 4 principles of object-oriented programming. Once again, encapsulation, abstraction, inheritance, and polymorphism. And those are what you learn those things in your basic object-oriented programming class. I want to talk for a couple more minutes here before we take any questions about some of the structures and kind of more day-to-day things that you see that relate to object-oriented programming in some ways, but are kind of more across the board coding principles and ideas and structures that you'll see that might have relevancy if you're interested in object-oriented programming specifically. But before I do that, any questions from Matt or Cameron about these 4 basics of object-oriented programming?
Cam, you got anything? That was a pretty good basic overview.
I don't think that after doing this, you're going to go jump in and being able to like get a job. But I do hope that after this, you'll be able to watch, like that scene from the Facebook. What was that Facebook movie called? Was it? You guys remember? A few years ago, they had
Uh,
a.
oh, The Social Network?
Is that the Social Network? Is that what it was called?
Yes.
All right.
Well, yeah, anyway.
Yes.
You
Anyway,
want us to watch movies after this. Got it.
exactly. Well, because there are times where I mean, software engineers are pretty ubiquitous. They show up all over the place now in movies and things like that. And sometimes they'll talk and be like, oh, that didn't make any sense. What are they talking about? Hopefully, you have a little better idea after we talk a little bit more about some of the specifics and get the general idea of what they do on the day to day. And then you also have a better understanding now of kind of the organization behind software. But yeah, I want you to be able to understand movies. That's my main purpose here. All right. All right. So a few things to watch out for in object-oriented programming. I think we talked in our basics of computers multiple months ago about memory and memory manipulation. And in most programming languages these days, you don't have to deal directly with memory. And I remember I mentioned that back in our basics of computers. So you can go back and listen to that as well. We talk a little bit about memory, but here on our day-to-day, on my day-to-day, and I deal every day in code. I don't have to deal with specific allocation and deallocation of memory. Meaning I don't have to tell my computer, hey, I'm creating an instance of an employee. I need this much RAM and I need, I don't have to do that. It just takes care of that under the covers, right?
Yeah, when you
However,
code, there are certain things that are already understood in the language. You don't have to get down to the specific of which bits and bytes to flip at which point.
right, exactly. Right. And all of this has been abstracted away. So once again, the idea of abstraction also comes in here that as a software engineer, I want to be abstracted from assembly language. I want to be abstracted from bits and bytes of memory. I want to be able to do what I specifically need to do to implement what I do for my company. I don't want to have to deal with all the nitty gritty of the actual computer hardware. However, that's not, it's, you do have to be aware as a software engineer of memory, at least at some level, because there are what are referred to as memory leaks. And I think a good example of a memory leak would be like, for example, I say to Matt or Cameron, remember the number 6123456. Remember that number.
Sure,
And then
not.
we go on. Right. So maybe you caught it, but let's assume you're a computer and you did catch it. You got that number. And I say, remember it. And then I don't tell you to forget it. And we go along and then I tell you, actually, remember the number 2358723. And we go on. And now I tell you to remember a new number. And let's say this goes on for a while. Eventually, as a human, let's say even if you've been able to retain a few of these, eventually you're going to run out of the ability to retain all of this information. And I've told you, remember them, right? So eventually you're going to just start forgetting. Well, a computer can't just forget. So if it's holding on to information, and you haven't, or either you explicitly have not, or the way the programming language is set up, it doesn't have the structure to be able to release that memory, you're just going to run out. And that's an overflow. So a memory overflow. All of a sudden, I'm out of memory. I don't have any more for you. And so the out of memory exceptions are things that you see. And so memory leaks happen in code still, even though I don't have to deal with it directly when I'm telling the computer, and maybe as a software engineer, I don't explicitly know that. This is why you do have to go through some classes and learn. You need to learn certain things, certain objects, certain classes, assume that the computer, or tell the computer, remember this.
So
And
what I'm a little confused. What you described as a memory overflow, that sounds like a bad thing. What is exactly a memory leak, though? Is it a type of overflow or?
it's what will lead to that. It'll lead to that. A memory leak is I'm continuing to retain memory. I'm continuing to use more and more and more, or at least I'm not getting rid of the memory that I have used, that I'm no
The
longer
term,
using.
yeah, the term leak seems a little counterintuitive. It's more like a memory backup, but or
Yeah. So
fog.
right.
But I
Um,
understand if you're not managing that correctly, you run yourself out of resources.
right. Exactly. And like I said, generally, if I create, for example, let's say I create an instance of a number in my C# code, I don't have to worry about if I have that in an object. When it goes, and this is, so when we're talking about memory leaks, a very important thing to learn is about scope. And scope is how long does this object exist, essentially? What is the scope of this object? Is it as long as this program is running, this object exists scope, meaning kind of a global scope? Or is this a local scoped object, meaning I exist in the context of doing a particular function, and then as soon as this function is done, I no longer exist. I'm in the scope of that function. And so the scope of an object will tell you how long it's retained in memory. So if I'm creating a number inside of a function, so that I'm creating the number of amount of money an employee makes in order to create the total expenses for a company. So I have a function that has calculate total expense. And so I run through each employee, I grab how much we're paying them, I add that number up, and I add it up, and I add it up, and I return it. So any numbers, anything created inside of that scope, my code, my computer knows as soon as I'm done with this function, get rid of that memory. We don't need it anymore. We returned what we needed to. We don't need any of that. It's scoped. It's out of scope. Get rid of it. And that's what we call garbage collection. So it goes through. It says, oh, that memory is not in use. Grab it back. Get rid of those bits in there. Flip them. Open them up. That's not reserved anymore. However, if you do not have correctly scoped objects, all of a sudden, if you're saving everything to a global scope, that's when you start running out of room, right? So, or if you're doing something with a file, as soon as you're dealing directly with the disk, those things have to be closed. And I'm saying open this file up and it exists on disk. And unless I say, well, now close it, it's going to assume I still want that. And so in Java and C#, there's something called iDisposable. So that's that I that I mentioned before with interfaces. And so any object that implements iDisposable is saying, I'm going to hold on to something. There is something inside of my object that when you create me, it's going to open. And unless you tell me to close it, that we're going to hold on to this memory indefinitely. And so if you have an iDisposable object and you do not dispose of it, meaning you don't get rid of that memory, then you've got yourself a memory leak, right? Then every time you do that function, you're just opening it again. You're not just using the one you had before. It's just going to keep on adding more and more memory. And so that's when you run into these issues of programs running out of memory and crashing. And so memory leaks are something you have to watch out for, and a very important part of understanding what goes on in programs. And once again, scope is a very important idea as well. So that's something I wanted to mention. I hope that kind of makes some sense. They very easily deal with it by just calling.
Yeah, I think that's good.
Yeah, calling that dispose method, just saying get rid of this. I don't want this anymore. So. All right, so a couple other things that I wanted to touch on were reference versus value, and this also still has more to do with memory, and this is kind of lower level stuff, but once again, something you do have to retain. So as a software engineer, you have to kind of know the difference. So there are objects, and once again, object-oriented programming, so it's important to understand what an object is, right? It's an instance of a class, instance of a structure, right? And there are objects that in memory we manipulate directly, right? And those are called value objects. So like a number is a value object, meaning if I manipulate that in code, I'm manipulating the value itself. I'm actually manipulating the memory. And then there's what's called a reference object. And so in that case, when I'm in the code and I'm saying, and that's like an example of a piece of text, and a piece of text in coding lingo is called a string. All right. So if I have a string, that's a string of characters, therefore text. If I have a string and I want to manipulate it, I'm actually not manipulating the object itself. What I've got is a reference to the memory. I've got a pointer. It says, hey, this is the pointer to the place in memory where we've got your object stored. And we could talk a little bit about the low levels, why that happens, but we're going to kind of gloss over that and just say that's the two different types of variables, two different types of objects that exist. There are reference and there are value. And value are very specifically enumerated. There are integers. You'd think I would remember all of them offhand, but it's a small number of things that you directly manipulate versus reference objects, which is pretty much everything else. Every object, so a company object, a employee object, a string object, these are all reference objects, meaning the code, it saves it in memory somewhere, and then it gives you a pointer to that place in memory. And so a reference object is something that they're handled differently, and it's important to know that because in coding, when I am doing a manipulation on a particular object, let's say I have a number of the way that you pass a number down into a function. So if I'm saying I've got this number of employees, let's say it's 100, and my company is now calling the add new department or acquisition method, right? I've acquired a new company. So I say, okay, this company's got 100. I'm going to pass that in, and I've acquired a new company. And so here's the new company, and this method's going to take care of all the acquisition. And what I'm expecting to get back is a new number of employees, right? Because I've acquired a new company. And you can, but what you've just done when you've called a method and passed in a value type is you passed the actual value, not a reference to the value. And so in the code where I called that method, where the original place where I've got that object, and I say, Microsoft.acquire, and I pass in some other computer shop. That part of code up there is now passing in that value, meaning what I've got, that number that I've passed in, if you expect that to change, it won't, because I just passed in a value, meaning directly that memory is now going to get manipulated, but it's going to get manipulated in that scoped method, meaning the parent method's going to continue having that original one, where that original value. However, when you pass by reference, I'm passing a pointer to an object. That pointer is going to remain the same. The underlying object can change, but that pointer is going to continue to pointing at that object, meaning when I manipulate that company object in the acquire method, that company is changing. In the apparent method, that company is actually changing because I'm pointing at that company instead of it's not directly the value of that company, if that makes sense. I get that's a little bit hard to.
Yeah, that was a little bit abstract. Could you maybe give a different example? Maybe use a car or a shape or something.
Sure.
It's like up an equation in Excel. So you can have, and then you do like, the little pull down thing where it copies the same cell to different things, but you can put different values into it, and then it just puts out the new number. Is that basically what you're saying?
Yeah, so I guess the best way to understand it is that when I pass by value, it's you're copying. So, and I didn't even really say that, so which is why it probably was so confusing. The idea is that value itself is now being copied. And so, it's when it's like the difference between photocopying something and handing the instance of it to someone. So let's say I want someone to fill out an expense report, right? And then give it back to me. If I photocopy this expense report and give it to them and they hand it back to me, I've now got two instances. I've got two expense reports, right? And if the original had everyone else's expense and now I've got this new one, I've got to merge them myself, right? I've got to figure out, HUD. However, if I've got the one original expense report and I hand it to the person and say, fill this out and give it back to me, then I've got all of the data in there together, right? And that's, for example, with an Excel sheet. If I send one Excel sheet out and I say, hey, everyone, fill out your expense report and give it back to me. What am I going to get? I'm going to get 30 different instances. I'm going to give, because let's say I attached it in an email. I've attached an Excel sheet. I've emailed it out to my employees and said, give me your expense report and send it back. If it's attached in an email, everyone's going to send back, and I'm going to have 30 copies of this expense report. That's fine. I just passed by value. I said, here's the value of this expense report. Here's an instance for you, and an instance for you, and an instance for you, and an instance for you. They're all going to manipulate the value and pass it back. And my original is still going to be unaltered. I've got the original copy, nothing in it, and now I've got 30 instances of a different expense report. Now, if I have let's say a Google Doc, all right, lots of people use that, or Microsoft 365 or whatever it is, and I say, hey guys, here's the link to my expense report, the company expense report. Everyone please go in, and there's a way to add new, and you can each add a line item for yourself or whatever it might be. Now I've got the pointer. I've got the pointer to the object, and that one object is being manipulated by all these different people, and when it's done, I still have one object and it's completely different. And so that's the idea, is when I pass by value, I'm making this copy. I'm giving you copy, copy, copy. And so if I'm expecting my original to change, I'm sorely disappointed. And I'm going to have some buggy code, meaning I'm going to have problems in it. Because if I expect, this value is going to be different now, so I can do different things with it. Well, no, if you ask them to pass back the value, then you can expect a new value back, but you're going to have your old value and your new value. Whereas a pass by reference is here's this instance of it, guys. Here's the link to the Google Drive. Everyone please fill it out. And now I know that link itself is now changed. It's still a pointer to the same object, but that object is now not the same object that it was before. Is that a better example?
I would say yes.
Okay. Thank you. Once again, as a learner from a layman, I don't teach software engineering. I do it. And so pass by reference, pass by value, very important, and understanding value types and reference types, underlyingly also important. But yeah, they're sometimes a little bit more difficult to get across. So a couple more, and then we'll wrap up here. So I've got loops, and this is there's particular things that you see a lot in software engineering, and that's conditions and loops. And this is just how we manipulate data and how we kind of structure things inside of these functions and methods, because we're getting in variables. And so we need to know, hey, if this is an employee, I need to do this thing. Otherwise, or else, do something else. There's something else that I need to do with a different object that they could have passed in. Or if this employee is taking the day off, do this. Otherwise, assume they worked 8 hours or whatever else. So that's a conditional, right? I've got a condition that employee might be meeting, and if they're not, then I need to, if they are, I do one set of calculations, and if not, I need to do a different set of calculations. A for is the idea that, okay, I'm passing in a list. I'm passing in a group of employees into this function. I'm saying, hey, do payroll. Here's my list of employees. Here, this function, do payroll for my company. And so now I need to go through each list, and this list could be 100, it could be 10,000, right? And so I need to loop over these people and do things for each one of them. And inside this loop, there's all this logic to figure out, oh, what kind of employee is this? Is this an hourly or salaried? And if it's a salaried, are we what's the salary and what rate, and if it's an hourly, what's the anyway. There are lots of things that can happen, but we have to loop over them. And so there's while loops, and while loops are while a condition is true, meaning while there are more employees, continue, and there's a for each loop, meaning for every instance of an employee inside this list, do this thing. And so the while loop is always conditional, meaning while something is true, continue. And so where a for loop is just iterate over every single one of these things. And so those are things you see all the time. Conditionals and loops are things that are in every instance of every method and function out there, almost always. And so that's something that you'll see all the time. And then let's see, one or two more things here. There's something called recursion, and recursion is something that you also see in the wild. Also, recursion is this idea that it's a mirror in a mirror in a mirror, right? And then you just dive down the hole. And recursion can be really useful in the software engineering. And one way, and this is something we used to do in our interviews for our companies, we would ask for people to code up the Fibonacci sequence. And if you're familiar with the Fibonacci sequence, it's recursive, meaning there exists some base values.
Every entry builds on the previous.
Exactly, right. And so your Fibonacci sequence has some base cases, meaning some basic numbers that so it's 0, 1, and then from those two base cases, when I have 0 and 1, then it's the next instance of the Fibonacci sequence is just the last two added together, right? So 0 and 1, I now add those two together to get 1, and then 1, and so now I need the last two. The last two are 1 and 1, add those together to get 2, 1 and 2 add together to get 3, and so on. So you can walk through that, and now you need to create a computer program that does the Fibonacci sequence. So let's say in this example, I want to give you the number in the Fibonacci sequence. Like I want the index into the Fibonacci sequence, meaning I want the 5th number in this Fibonacci sequence, not the number 5, but whatever the 5th number is in the Fibonacci sequence. That's what I want you to hand back to me. That's the value that you're going to give back. And so there are a couple ways to solve this problem. And the natural one is to say, oh, this is a recursive problem, okay? And that's to say, okay, well, if I can get down to my base cases where a condition is met that this is a base case, either 0 or 0, then I can just pass that back. Or I can say recursively, just subtract, and go back down to your base case and then add them up. So calculate the Fibonacci sequence for 0 and 1 and add those, and then call, if it's not that, just call the Fibonacci function for the index -1. Because when you get down to that condition where the base case is met, you'll hand up 0, you hand up 1, and then you just add each one of those recursive calls, and then you'll get the solution, if that makes sense. So it's a very simple, it's like a 4-line method. If it's a base case, give me 0, give me 1. If it's not a base case, call this exact function again with a lower index, meaning -1, go. And then if that one's still not a base case, add whatever the value is going to be for that one to recursively called Fibonacci sequence -1. And you'll get down to the base case, and then you'll start adding them up. And so it's recursion can be very useful when trying to say, okay, I need to get down to the bottom of this, and it's recursive. I need to walk down this tree. Let's say a structure, a tree structure is pretty common in software engineering as well. I need to walk down this tree all the way to the bottom. So recursively get down to the bottom and then walk back up. That's great. Recursion is very useful. The problem is if recursion is not bounded by some level of reasonable numbers, your computer is going to run out of room in your memory stack. You have a stack of memory that you can allocate, and you can overflow that, right? We talked about that a little bit earlier. And so if I have a stack and I just ask for the 10 millionth indexed version of a number in the Fibonacci sequence, every time I call this function, my computer's throwing more memory on the stack. It's saying, oh, need more memory, oh, need more memory. And if I just call it 10 million instances of it, even though the numbers we're talking about are ones that a computer can handle, it's continuing to chuck memory at this every time I call a recursive function. And so what we get is called a stack overflow. Parenthetically, also the name of a very useful website in software engineering world. Stack Overflow is the one that most people turn to with questions and day-to-day coding. It's a community-driven site where you can go and post questions and get answers. We're not talking about that. That's very useful. This is actually a Stack Overflow in your program where I say, I've got too much memory stacked here. I'm out. Boom, pop, I'm done. So the recursive algorithm has that potential unless it's bounded in some way by either real world, like I can't go deeper, a tree can't get taller than, some reasonable length. Like it's never going to run out. A tree can't get 10 million feet tall, right? For example. And so recursively, I know I'm probably safe. However, the other alternative as opposed to a recursive thing would be a loop, right? Is figuring out how can I calculate this thing in a loop, and then I have to store a couple of values and manipulate those, but that's easier than recursively adding memory. Questions about that, Matt or Cameron? Recursion is a pretty simple topic, I guess, but in computer science it's pretty useful to understand it and also understand what its limitations might be. I'll take from the stunned silence that I did well.
It seems like a recursive thing for prime numbers could be useful.
Recursive thing for lots of different functions are useful. The problem is, once again, when you get to high values and recursion is unbounded by anything. If your user is there and saying, haha, let me bring this program to its knees, give me the 100 billionth prime number. Well, HUD, I just crashed. There's no way any computer can do that, right? And so that's why you have to be very sensitive to what is the bound of this recursion? Like, what is the bottom of this? What's the floor? Where's my base case and what's my potential top? And where am I going to blow up here?
So if I just wanted to crash a computer system, if I got in, I could just set up a simple recursive thing and then just crash something?
It'll crash your program. Yeah, I mean, these things are all abstracted away from each other. So, yeah, you can bring a computer program. You can crash any program you want to by calling a recursive, and it'll just pop your stack right away. Like if you want a hello world recursive, hello world, I mean your basic program that you see. And then call it recursively, you'll find an exception very quickly. And an exception is an error, meaning I've broken somehow. I've broken and I can't get up. An unhandled exception, meaning an unhandled error, meaning I don't know what to do with this, meaning I'm out of memory, or this number overflowed the amount of memory you gave me for it, or I called an internet protocol, but guess what? Your internet's not connected. Pop. Any of these unexpected changes, or I divided by 0. Computer, good luck. Like these are all like, oh, that's an exception, meaning I've got an error here. And so an unhandled exception means I don't know what to do with it, crash. So yes, if you go into hello world and recursive it, meaning call itself, you're going to get a stack overflow and you're going to crash your program. It's not going to crash the computer because it's abstracted. Your computer has said, hey, this program is going to get so much memory, and we're not going to worry about what happens if it crashes. Matt, any questions?
But I guess I'm more saying that's basically how people crash your computer, right?
That's not the only scenario. Recursion is a scenario that you'll run into, but yeah, I mean, there are lots of ways to crash computers. But yes, memory is often one of them, and it either be a memory leak or a recursive issue or just I'm manipulating data that's way too large for what I expected. All of those things can happen. Matt, anything else?
Not for that one, no.
All right. Well, I didn't have a lot else I wanted to talk about. We could talk about other data structures, but data structures could be its own podcast.
Well, I'm kind of wondering, for the first part where you talked about object-oriented programming and the characteristics of it, I think that fit. I'm not sure the discussion on recursion and everything else, all the other methods, does that align with object-oriented programming specifically, or now we more in like general programming terms?
Yeah, it is a little bit more than object-oriented, but I think it's important to understand in object-oriented realm.
In that context, yeah.
In that context of like a memory leak happens in object-oriented programming, and if you're not aware that when I create an instance of an object that has iDisposable, I could shoot myself directly in the foot. Yeah, and recursion also, once again, if you've got a recursive method in an object, you're going to pop your program real quick if you have an issue. So yeah, some of these aren't directly. I tried to stay away from, like I said.
Yeah, no, that makes sense in that context then.
All right. Well, if there are no other questions, we'll wrap up here. We've got more podcasts coming down the pipe here. We've got. I'm going to tease a new and distinguished guest coming on the podcast in the not too distant future. That will be a first for the Learn It From a Layman podcast. We're going to interview our mutual uncle, who was the director of the American Institute of Taiwan. And he just finished up his tenure there, and he's agreed to come on our podcast and talk a little bit about Taiwan with us. So that should be awesome. I'm really looking forward to that, and look forward to that podcast in the near future. So, but for object-oriented programming, if you have any questions or anything, find our Facebook or Twitter. Let us know if you have other things that you'd like us to address, and we will see you back next podcast.